So the last topic for Module 1 is missing data. Let's jump right into examples in order to better understand what that means. So example number 1, for the given closed traverse shown, you have lines A, B, C, D, and then going back to A. So that's a closed traverse. You have your bearings and distances, and then the surveyor wasn't able to get the bearing of line DE and EA. So now we have to compute for that missing information. So first, compute bearing of line DE, then bearing of line EA, and then finally the area of the lot. So let's begin with getting the bearing of line DE. Now, whenever we have something like this, wherein the final lines are the ones that's missing, we can just try to first close the given line. So we'll create a shape out of the given and then close the line. So we form a new shape. So what I mean by that is this. So let's try drawing out what's given first. So we have line AB. Okay, so line AB is from south going to west. So I'm gonna start here on a little more on the right side since the line is gonna go west. Okay. So here, let's say N. So let's just estimate that bearing. So from south, like 35 degrees, something like that, going west, and west is this side. So that line would be something like this. Okay. Again, bearing, it's from the south line. This is 35 degrees, 30 minutes west. Okay, so that's your AB. Now remember, one thing to take note here is the way you're gonna draw your line depends on what letter comes first in the label. Okay, so for example, AB, so that means you're starting at A. The bearing is taken at A. So this is your A. And then this ending line or ending point is your B. Next, BC is from north, 57 west. So let's draw. So that's starting at B. So here. So this is your north line. Gonna go west. So here. Okay. So this is your 57 degrees, and then this would be your line BC. Okay. So I'll just do that now. And then take note of your length. That's 44. BC is so much longer than that. So try to draw it that way. Okay, so longer. This is your C. Next, CD, 1 degree, 45 east. So starting at C, so this is your C. So just a very tiny amount. And that's your 1 degree, something like that. And then length is 12, so it's pretty short. Okay. So let's do that. Let's do that. A, B, C. This is your point D. Now there's another point, DE, and then EA. So E is somewhere here. Okay, we don't know yet. But, okay, it's safe to assume that for a closed traverse, they're all non-oblique angles. So meaning it won't be greater than 180. Okay, so your E won't be here, because that will create an angle greater than 180. Okay, so your E could be somewhere here. And then this length is 64 DE, so it's closer to D than it is to A. So something like that. And this is the missing data. Okay, and so that's your temporary closed traverse. Now, in order to solve for these two, what you can do is solve or close your given polygon. So this is what's given. Okay, when I mean close, I'm gonna draw a straight line from the last given, which is your CD, to your original point. So here. So like that. Okay. And then I can actually solve for dA using the concept of latitude and departure. So let's try doing that. Okay. Okay, so let me copy this, and then all I need is the latitude and departure. Okay, so latitude, departure. So for this, let's try storing all of our values instead of rounding off. Okay, so I'm gonna do latitude column first, then later on I'll ask you to do the departure column. Okay, so latitude, remember equation is length times cosine theta. So that's 44.37 times cosine 35. And that's south, so that's negative. And then solving for that, you should get negative 36.12. Again, you're going to store the total value of this in your calculator. Next, we see 137.84 times cosine 57. That's north, therefore positive 74.57. And then CD, that's 12.83 times cosine 1 degree. You should get 12.82. And then that's north, so positive. Now remember, we're closing the traverse, therefore I'm going to ignore these lines. So I'm going to delete that. Okay. And then the last line would be from letter D to letter A. So instead of DE, this is now DA. Okay. And then, remember, we have a rule for closed traverses. In order for it to not have an error, the summation of latitude should equal 0. Okay, once again, summation of latitude should equal 0. In that case, given that information, what should be the latitude of line DA in order to close this, or in order for the summation of all the latitudes be 0? Can anyone give me the answer? Correct, John. Okay. And also Jasper. It's negative 51.27. So to get that, that's just a summation of all of this. You'll get positive 51.27. But again, I need it to equate to 0. So instead of positive, you'll take the negative. So again, summation of this positive 51.27. Therefore, I need a negative so that the summation of all of this is 0. Okay? So that's how you complete the latitude departure for closing a traverse or adding a new line to your traverse. Next, let's do the same thing for departure. Can anybody give me departure of line AB? Correct, RDL and oh, oh, and Carl. Sorry, Glado. Lapid. Correct, it's negative 25.77. How about BC? Correct, Zaira and Kian. So Kiben Tenolier. So once again, store all those values in your calculator in the meantime. We're going to use it later. So negative 115.93. How about CD? Correct, Zaira and KB, Escobar, Benolier. Okay. 0. And then how about dA? Very good, RDL and John for Scarlett. Okay, so once again, to get the departure of dA, that's just taking the summation of this, which is negative 141.30. And again, I need the summation of departure to equal to 0. So this would be positive 141.30. Okay? And so that's the latitude departure of dA. Now let's check if that is consistent with our drawing. So latitude is negative, that means it should be going south. Departure is to the is positive, so that should be east. And if you try to get the bearing of this, if I draw the north-south line, that is indeed from the south going east for its bearing. Okay, so our drawing is accurate. Right, next. So what will I do with this information? Okay, upon getting your latitude and departure, you can actually get the bearing as well as the length of line DA. Okay, so let's try getting that. So distance. Okay, distance is given 44. I'll just, that's the same here. And then to get distance of DA, okay, that is, considering latitude departure again are the x and y components of a line. To get total length of the line, that's using Pythagorean theorem. So DA is just square root of negative 51.27 squared plus 141.30 squared. Please compute. What's the answer? Again, you're going to use the stored value of everything. Correct, Geraldine. Again, use stored value of this. So only Geraldine got it. Lazaro. For those, if you're just copying off of Besavilla, okay, just know that they're rounding off values. So please compute it with me. Don't just copy what you see on that reference book, okay? Because again, you're going to get a different answer from me. So using stored values, you should get 150.32. Okay, so this is 150.32. Once again, store that value as well. And then you also need, or from latitude and departure, you can also get the bearing of your line. Okay, so to get bearing, let's just make this smaller. So to get bearing, that's your theta. Theta would be here. Okay, from this north-south line, this is your theta. Okay, and you can solve for that using trigo functions. Okay, recall, if you're given bearing, if you're given x and y components or latitude departure, theta is just arctangent departure over latitude. So that's arctangent 141.30 over 51.27. Give me the answers in degrees, minutes, seconds. Correct, Geraldine? Again, please use stored values. Come here, compute. Okay. Okay. So this is 51.26963.155. Okay. So that's all for latitude. Now let's get the departure. Okay, so just to recheck if this is in fact 32 or 31. Okay, just rechecking. Okay, then sine. Let's check for departure. Okay, and that is 141.3027986. Okay, getting square root of each. Yeah, that's 150.3165194. And okay, if we're using the whole value of it, so that is indeed 32. And then you're gonna use this as well to get arctangent. So let me check who got the correct answer. Please recompute again using the the complete values. So Geraldine, you're correct. And then who else? Carl Arreglado. Okay, so Geraldine, Lazaro Arreglado. Okay. Okay, so ganun. So in case, oh, you're not disregarding negative for the latitude. For arctangent, yes, that's, you're getting the angle and absolute value. If that's what you're asking. Okay. So once again, that is 70 degrees, 10 minutes. Oh wait, 3 minutes, 26.8 seconds. Okay. Okay. And then from this, I can get the bearing of line DA. So bearing, to get the directions, just look at the sign of your latitude departure. This is negative, therefore south, 73, 26.8 seconds. And then this is positive, so that's east. Okay. So I still haven't actually solved for what's being asked, which is bearing of DEEA. What I got is bearing of DA. Okay. So I'm going to use my newfound value for DA to solve for what I need, which is the bearing of DE and DA. In order to do that, okay, you're going to use your equations for a triangle. Okay. So let's start with getting bearing of line DE. Okay. So bearing of line DE, that would be the acute angle or smallest angle from either the north or south line. So that means what I need is this. Okay. So I need that. I've already solved for theta, right? So all I need is to get this in order to get the bearing of line ED or DE. Okay, so starting at D. So let's call this alpha. Okay? And then I just subtract 180 because this whole thing is 180 minus theta minus alpha. I'll get this bearing. Okay. So now how do we get alpha? Again, remember your trigo function. So I'm going to write out some of our given. Length of DE is given, that's 64.86. Length of EA also given, 106.72. Okay? And then, this length is also known now. We figured that to be 150.32. Again, use the stored value, okay? Which is this one. We have three sides. I need an angle. I can solve for the angle using cosine law. Right? So recall cosine law. C squared equals A squared plus B squared minus 2 AB cosine capital C. Okay, so C is the angle subtending side C. So that means using this, I need alpha. So your subtending line is 106. So this would be 106.72 squared equals A squared. 64.86 squared plus 150.32 squared. Again, you should use the stored value, okay? Minus 2, 64.86, 150.32 cosine alpha. From this, we can solve alpha. Please give me the answer in degrees, minutes, seconds. Again, this is what you'll use for 150.32. Correct, RDL. Wells. Again, degrees, minutes, seconds. Correct, Kian. Kiben. Okay. So the answer is 37 degrees, 46 minutes, 26.12 seconds. And from this, I can get bearing of line DE. Okay, again, that's 180 degrees, this entire thing, minus theta, which is this, minus alpha, which is this. Please solve. What do we get? Correct, Jasper. And yes. Correct, John. Carlo. 2 points. Also correct, Michael. Okay. Ma'am, bakit hindi pwede alpha mismo ang bearing ng DE? Because alpha is not from the north-south line. Bearing is always from the north or south line. So I need an angle in reference to that. Okay. And this is what I'm trying to get. Okay. Right. Okay. And then correct, the answer here was 72. Then 7.08. Okay, and then to get the final bearing, once again, you're gonna look at the sign of your latitude departure for D. You don't have to do that. You just have to look at how you drew this. So that's north going towards east. Okay, so that's north. 72, then 7.08. Okay, so that's the answer to letter A for number 1. We'll do the same thing for EA. Okay, once again, I need a certain angle. So this is EA. Right? I need this. I need this angle. Let's call that beta. Okay? And then, in order to get that, if I manage actually, let's call this beta. Ito na lang yung beta. Okay? Yeah, 72 degrees, 10 minutes, 7.08 seconds. E. Okay, E. Forgot the E. Correct. Okay. Okay. Again, what I need is this angle. Okay, that would be the bearing for line EA. Okay, since this E is the first letter, so the basis is from point E. Okay, let's call this gamma. Okay, let's use gamma. Okay, so now I need to get that angle. So in order to get that angle, one thing that we can do is solve for another angle on this triangle. Okay, so let's try using, if I can get this total angle, okay, let's do that. This total angle, alpha is just that total angle, gamma is just that total angle minus this. Okay, and this is also just beta, okay, because of law of alternating interior angles. So beta here, yeah, this is also beta. These two angles are the same. Okay, this one and this one. Once again, if I manage to get this minus beta, that's your gamma, that's immediately the bearing of line EA. So now let's try to name this angle. I'll call it sigma. Okay. All right, so now the goal is to get sigma. So once again, remember some of your equations for a triangle. We've used cosine law. Okay, I need to get an angle. Let's try using sine law. So recall sine law. That's just sine A over length A equals sine B over length B. So let's do that. I need sigma. So sine sigma over the opposite length. So that's 150.32 equals. Then you're gonna, since this is what I know already, okay, I'm gonna use that. Since that, again, that's the only angle that I know of for this triangle. So equals sine alpha over, and then its opposite length, 106.72. Okay, then using this, you can solve what's sigma. Okay. Did anyone get it? Wait long. Okay, so I'm gonna scrap this because we're getting an erroneous answer. So instead of solving for this, okay, and instead let's try getting this one. Okay, this is still your sigma. Let's call this sigma. And then if I draw a straight line here, okay, this would be equal to this, and then this is what we're looking for. That's your gamma. All right. So now what I have to get is this angle. In order to get that, I just have to get this get sigma. Okay. And then theta would just be this total angle minus sigma. And we know the angle of this, right? That is this entire thing is theta. Okay. All right, yan. Okay, once again, let's visualize to make things clearer. So this angle is equal to this angle, right? Because they're from the same line, and then from the north-south line. So they're alternating interior angles. Okay? And then, once I get sigma, I'll subtract theta and sigma to get alpha. So now let's just try getting sigma. Still using sine law. So sine sigma over, now its opposite length is this, 64.86 equals sine. So we're going to use an angle that we know, which is alpha. So sine alpha over opposite length, which is 106.72. Okay. Also, this is the better choice to use because we're not relying on too much on our solved values. So we're using the given length of DE and EA. We're no longer using the solved for length of DA. Okay. So now using this equation, let's try to solve for sigma. Please solve. What's the answer? Okay, correct. RDL. Wells. Okay. Okay. Who got it? Correct, Jasper. Yes. Sige. Also, Maro. And then Carlo. Right. Yeah. So the answer here was 21 degrees, 51 minutes, 22.89. Okay. And then from this, we can now get your bearing, I need sigma. I need gamma. Gamma is equal to theta minus sigma. Okay. Theta is this. Sigma is this. Please solve. What's the answer? What's gamma? Correct, Carlo. And Kian and Jaiser. So, De La Cruz, Rizcal, then. Then, also, may humabol, also, Alexandria. Right, so that was 48 degrees, 12 minutes, 3.91 seconds. And then from this, we can finally get bearing of EA. Okay, so the first letter is E, so this is where I'll base my bearings on. Okay, so that would be from south going to east. So that's south, 48, 12, 3.91, east. And that's it. Okay, so that's part 1 and 2. And then question number 3, compute the area. So we already know how to compute the area for this kind of given distance and bearings, right? We can just use your DMD or DPD method. Okay, so it's up to you which one you want to choose. In the exam, I'm going to specify which method to use. Here, it's not specified, so we can just choose either. I'm going to choose Dmd method. Okay, so to do Dmd method, again, let's try using this table. So remember, for Dmd method, I also need latitude departure. Okay, so I can just copy from A to D since they're the same. So this is still negative 36.12. Remember, we're going to use stored values, okay? Positive 74.57, 12.82, and then departure, negative 25.77, negative 115.93, 0.39. And now we can complete the table since I already know the bearings of DE and EA. Since we know the bearings, can you give me the latitude of line DE? So that's just distance, 64.86 cosine this one. Cosine its angle. Correct, Jan and Carlo. Yahoo. That was 19.86. What about for EA? Correct, Jasper and Carl. Reglado Viernes. Viernes. Don't forget the sign. So that is latitude. So that is south. That's why this is negative for EA. So negative 71.13. Again, store all of these values that you're getting. You can just write the total or all of the decimal places if you want, if you don't want to store it all. Okay, so 71.13. And then let's do the same. What's the departure of BE? Correct, Zaira and Jan. Penolyar Lahong. Okay, that was 61.74 positive. And then how about for EA? Correct, Jan and Jizer. So correct, Rahong de la Cruz. Also, Angel Zalika. Okay, all right. So that's positive because they're east. East, east, so both positive. Positive 79.56. Okay. So keep in mind, we're using all of the stored values of this. Okay, we're only rounding. There's no rounding off that's happening yet. Okay. So now Bnb method, we're gonna get Dmd, and recall Dmd for the first one is just the same as the departure of the first one. So this is also negative 25.77. I'm gonna complete this table, so follow along. Let me know if I did any computations wrong. Okay, and then to get the second row, that's this plus this plus this. You should get negative 167.46. And then adding this, this, and this, we should get negative 283. And then this is negative 220.86. And this is negative 79.56. Right. And as you can see, remember there's a rule for the last row or last line. The DMD should be the same value but opposite sign. So since that's what I got here, that means I did the DMD correctly. Okay. Now if we round it off in any part of this solution, this won't be equal. Okay. So that's why I'm not having you round off anything yet. And then the next step is to get DMD times latitude. Okay. I'm gonna solve this as well. You can just follow along. I'm gonna include the entire value. Since at this point, there might not be enough variables in our calculator to store all of these numbers. So I'll just write out the entire value itself. So DMD negative 25 times negative 36, you'll get positive 930.71974443. Then here, this is negative 12487.17374. This is negative 3629.163257. This is negative 4386.571955. And then finally, negative times negative, that's going to be a positive 5659.066462. And then the next step, okay, I'm gonna just delete this now. And I'll move this here. The next step is to get the summation. Okay, please add what's the summation here. Correct, Alexandria. And Denzel. That's negative 1, negative 13913.12275. And then to get the area, that's just 1/2 absolute value of the summation of your DMD times latitude. Okay, so what's our final answer? Rounded off to 2 decimal places. Correct, Maro and Jasper. So Viernes Casople. Okay, the answer is 6956.56 meters. Therefore, area is meters squared. That's all of your answers. Okay. All right, so we're done with number 1. Do you have any questions for number 1? Please answer in the chat, clear or none, or your question. Okay, question, ma'am, bale, wala na pong application ng correction sa missing data problem. Yes, there's no correction here anymore. Okay. All right, no questions. Let's move on to number 2. Okay, so number 2 is a bit shorter. Okay, since it's easier to get the area. So let's see, number 2. Closed traverse shows tabulated values of latitudes and departures. Number 1, compute DMD of line 3-4. Okay, so let's focus on that first. I gotta get the DMD of line 3-4. So this is my given. To get DMD, okay, you're gonna recall again our principle for latitudes and departures. Remember, summation of latitude for a closed traverse should be 0. Same with summation of departure for a closed traverse should be 0. So using that concept, you can easily solve for latitude of this and this, since there are only one single missing value for the entire data. Okay, so let's get the latitude of line 6-1. Okay, again, you're gonna take the summation of this, and then since it has to be equal to 0, you're gonna get the negative of that. Can anybody give me what should be the latitude of 6-1 in order for the summation of latitude equals 0? Correct, Sebastian and Zelica. So Cruz, Angel. Okay. So that was negative 151.38. Again, this is positive 151.38. Okay, so in order for everything to be 0, I need a negative 151.38 here. Okay, so same concept as well for departure. That's departure for line 1, 2. What's the answer? Correct, Kian and RDL. Lapid, Ben. Lapid. Kiben. Right. Positive 37.70. Right. And now, since we know that, I'll just place that immediately here to make things easier for us. So 1 negative 151.38, and this was positive 37.70. The goal here is to get Dmd of line 3, 4. Right, so let's try getting that. Okay, Bnb. Remember, Bnb for the first row is just the same as the departure of the first row. So this is also 37.70. What's the Dmd of 2, 3? Correct, Kian? Yeah. And Jan. 19.29. How about for 3, 4? Correct, Kian. Negative. And then Alexandria. Correct. 94.34. Negative. Okay, and that's what we're looking for. So therefore, the answer to letter A or number 1, Dmd of line 3, 4, that was negative 94.34. Okay, next, what else? Length of line 6 to 1. So I need to get length here. Okay. Remember, to get length, if we're given your latitude departure, all you have to do is use Pythagorean theorem. Negative 151.38 squared plus 47.63 squared. What's the answer? Correct. Sebastian and Carlo for the Sky Cruise. Okay. It was 158.70. Okay. And then, final question here is bearing of line 6 to 1. Okay, bearing. That means that's just getting the theta first. Theta is arctangent. Absolute value of departure over latitude. So 47.63 negative 151.38. Again, absolute value, so you can just disregard that. What's the answer? Okay, correct. Jan, so Denzel, Lahom, and Geraldine Lazaro, Lahom. Okay. Okay. The answer is, so we're gonna use your degrees, minutes, seconds as well. So that was 17, 27, 56.13 seconds. And then to get bearing of 6-1. So looking at the sign, your latitude is negative, therefore that's south. Copying your value. And then departure is positive, so therefore that's east. Okay, and that's it. That's it for number 2. Do you have any questions for number 2? None? Don't have any more questions. If you have questions, please answer in the chat. None, clear, understood. So let me know if I can move on to the next problem. Okay, great. No questions. So I can go to number 3. Number 3, given the following traverse notes for a closed traverse, number 1, compute the total length of the traverse. So I gotta get total length. There's a problem there. I need the distance of CA then. Okay. So in order to get that, since this is 3 lines only, what kind of shape are we gonna get if we're only getting 3 lines for a closed traverse? What do you think? Correct, KB and Geyser. So De La Cruz Escobar. It's a triangle. So I can immediately draw this and then use equations for a triangle in order to solve for the missing parts. Okay, so let's do that. I'm going to start with AB. Now, instead of bearings, we're given azimuths. Now, remember azimuth for our section. Azimuth is always starting from the south line or south meridian. Okay, so this is your south. If you're starting at A, going clockwise, so that's 225. So that's somewhere here. And something like that. Okay? Ayan. Some might be wondering, how did I know that's 225? Because if I draw this line, this is 90 degrees, 180 degrees, this is 270 degrees, right? 9, 18, 27. 225 is less than that. So I'm not going to cross this line. So it's just somewhere here. Okay? So this is your 225 degrees. And that's your line A and B. A to B. Okay? Next, azimuth of BC. Okay, so BC is longer than AB. So keep that in mind. And then get the azimuth. 346. So that is somewhere here. Okay? So it's almost a full rotation, but not quite. So it's just somewhere there. And then it's longer, so like that. Okay? And that is 346 degrees. And again, this is line B. Okay? And what I need is CA. This one. So C to A. Yes. For azimuths, it's always starting from the south line. Okay. Okay, and then let's write out the length. This is 1,200. This is 1,400. All right. So let's try getting AC first. Okay. I'm given 2 sides. If I can figure out the angle between them, I can get the opposite side AC. So the goal here first is to get whatever this is. Okay. And that's pretty easy because if this total thing is 346, then this is just what's remaining from a full rotation. So 360 minus 346, you'll get 14 degrees. Okay? Because again, let's blow that up. This is your 346. What I need is this one. So that's just 360 minus 346, which is 14. Next. Now I have to get this angle. Now you're going to try to look, what do we have? I have a 225 here, right? If I can also get this angle, that angle is equal to this because of alternating interior angles, right? So to get that, remember, this is 225. Okay. Again, I'm gonna try to enlarge that. Okay. This is 225. I just need to get this because that's equal to this as well. How do you think we'll do that? How do I get theta? Correct, Ian and Geraldine. So Lazaro then. So remember this is 225. This angle is 180. Right? So that's just 225 minus 180 degrees. I can get this. Okay? And then 225 minus 80, that's 45 degrees. Okay? So I'll write that. This is 45. So 225 minus 180, that is 45 degrees. Okay? Okay, so now I have this. Therefore, we can conclude this total angle is just 59 degrees. Right? Because that's just 45 plus 14. And now I can create my cosine law equation. So c squared, so that's this line. So let's call that AC squared equals 1,200 squared plus 1,400 squared minus 1,200, 1,400 cosine 59. From this, please solve what's AC. Correct, John. And Mark. Villalobos. Alright, that was 1292. So AC 1292.08 meters. And that's one of the first things that is Wait. So this is 1292.08. Therefore, total length. Okay. That would be AC 1,200 plus 1,400 plus AC. What's the answer? Correct. RDL, Zyra, Familiar, Shetty. Ay, sumagot bang ibang correct Mark as well. Then Michelle. Mark Villalobos Reyes. Okay, that was 3892 meters. And that's our answer. Next, part B, what we're looking for, azimuth of line CA. So CA, therefore what I want to get is this. Okay, let's call that theta. So how to get that? If I can get this, and then I know that this is actually 14, because again, alternating interior angles. So here, and they're alternating 14, 14. If I can manage to get whatever this is, I'll just get 180 minus 14 minus that. I'll get theta. Okay. So I'll call this alpha. All right. So now the goal here is to get alpha. And then to do that, we can use sine law. So sine alpha over opposite 1200 equals, I'm going to use what we know. Okay, I know this angle, so that's 59 over opposite side, length AC. And I already know length AC, that's 1292.08. And don't forget, you're using the stored value of that. Okay, so from this, please solve what's alpha in degrees, minutes, seconds. Correct, John. First, who else? Correct, Lapid. That was 52:45. 52 degrees, 45 minutes, 26.92 seconds. Okay, and then to get theta, that is 180 minus alpha minus 14. And that's 113, 14, 33.08 seconds. Okay, and that's immediately your azimuth because that's from the south line. Okay. And then finally, we want to get area of the lot in acres. Okay, area. This is a triangle. Can you give me what equation should I use to get the area of this triangle? It's not Heron's formula. Well, you could, but that's going to take too long. There's a shorter way. What's the easier way? Okay. Again, it's not Heron's formula. Correct, Geraldine. Okay, the answer here is using your side angle side. Okay, so side angle side, or that's your 1/2 AB sine theta. Okay, so I can just use any two sides since we've basically figured out all of the angles. I'll use this one. Okay, side, the angle between, because that's based on the given only. I don't have to rely on the computed values if I use that. So 1/2, 1200, 1400 sine theta, angle between them, which is 59. Okay, so I'm gonna solve. That is 720, 0.53 meters squared. Now, here's the catch. I want to get the area of the lot in acres. So you gotta convert meter cubed to meter squared to acres. Now, the conversion there is 1 acre equals 4,046.86 meters squared. Okay, so using that, so 720,020.53 conversion factor. Okay, 1 acre is 4046.82 meters squared. Meters squared will cancel out. Final answer is 177.92 acres. Okay, and that's it for number 3. Do you have any questions for number 3? Please answer in the chat. Okay. Since you don't have any more questions, 86 or 82? Let's double check. Acre to meter squared. 86. Let's use 86. Ah, because I wrote it here. Okay. 86. Yeah. Okay. All right. So I'm gonna end the lecture here because we're out of time. On Saturday, you're gonna have your seat work. Okay. So there's no Zoom meeting on Saturday because you have your seat work. It's gonna be available at 12 a.m. Okay. It's gonna be available at 12 a.m. Deadline 11:59 p.m. You have 3 attempts for the seat work. And then tomorrow we'll have fieldwork meeting, 12 o'clock. Okay? So I'll see you tomorrow. So since you don't have any more questions, you may go. See you tomorrow. Goodbye, class.
Thank you po,
Thank you,
ma'am.
ma'am.
Thank you po.
Thank you, ma'am.